Hi everyone, and welcome to an overview of using formulas in geometry. This is video 2. We're looking at surface area and volume. So let's start off by looking at our three-dimensional figures and identifying them and figuring out which formulas we need. When first approaching a problem, it's really important to identify the type of shape you're working with. You need to tell if it's a prism, a pyramid, or a sphere. So prisms, which are my blue shapes here, have the same base on both sides. So notice my triangular prism has the triangle on both sides, and it's connected with the rectangles. My rectangular prism has the rectangle base, and it's matched by the same shape on the top, again connected with all rectangles. So it has two of each base. Now remember, these are three-dimensional shapes. You can turn them on their side and it's still going to be the same type of shape. So I always look for the unique type of side. They should all be rectangles and then two of the sides should be the base. So the unique shape here is the triangle. The unique shape here is going to be the rectangle at the bottom. You can even use these formulas on cylinders as well. They would be considered similar to prisms. For pyramids, notice how you have a base, but on the other side where the other base would be, it just comes to a point. This is a triangular pyramid, and this is a rectangular pyramid. And the sides on this are all triangles. So that's going to affect our formulas. So it always comes to a point at the top, and there's always a base that's a unique shape. So once you recognize what type of shape it is, it's always a good idea to calculate the perimeter of the base and the area of the base, because those are used in basically all of our formulas. So I always calculate that first, then I take those numbers and put them into my formulas for volume or surface area, depending upon which one I'm looking for. For prisms, the volume formula is the area of the base times the height, and the surface area formula is 2 times the area of the base plus the perimeter times the height. For pyramids, the volume is 1/3 times the area of the base times the height, and the surface area is the area of the base plus half the perimeter times the slant height. Now in pyramids, you have the height that goes from the middle of the base to the top, and you have the slant height that goes up the side of the pyramid. So make sure you're careful. This height is the actual height up the center of the pyramid, and this height, the L, represents the slant height from the edge all the way up to the vertex. Now for spheres, the volume is 4/3 pi r cubed, where r is the radius, and the surface area is 4 pi r squared, again where r is the radius. So let's take a look at some example questions. In example 3, we're asked to find the surface area and volume of this cylinder. Now, in my opinion, this falls in the shape category of prisms, because notice we have a circle on this end and a circle on that end. So we're going to start off by finding the area and circumference of those circles, because those are our bases. The height is always the distance between the two bases. So we're going to find those and then put the numbers into the formulas to find the surface area and volume. The radius of the base is 1 because it's half the diameter. So for the area, you get pi times the radius squared, which is just pi. For the circumference, it's 2 times pi times the radius, which is 2 pi. The volume of this is going to be the area of the base times the height, which is the distance between the two bases. So you get 5 pi meters cubed. And the surface area is going to be 2 times the area of the base plus the perimeter of the base times the height. And you get 12 from that. Let's take a look at more examples. In part B, we're asked to find the surface area and volume of this rectangular prism. I know it's a rectangular prism because all of the shapes are rectangles and it does not come to a point at the top. So we're going to start off by finding the area of the base and the perimeter of the base, and then taking those values and putting them into our formulas. The area of the base rectangle is 9 times 7, which is 63. The perimeter of the base is 2 times 9 plus 2 times 7, which is 32. To find the volume of this, I take the area of the base and multiply by the distance between the two bases, the height. And that was this 14 here. You get 882 feet cubed. For the surface area, it's 2 times the area of the base plus the perimeter of the base times the height. And you get 574 feet squared for that. Let's see more examples. In example 4, part A, we're asked to, again, find the surface area and volume, but in this case, they didn't give us a picture. They're just describing it. It says it's a square pyramid with base edge length of 5 inches, height of 7 inches, and slant height of 9 inches. Now, note that this is a square pyramid. The base is a square. So we're going to start off again by finding the area of the base and the perimeter of the base, and then we're going to put it into our formulas. For the area of the base, it's the side length times itself, which is 25 because it is a square. For the perimeter of the base, it's just 4 times the side length, or 20. For the volume of this, it is a pyramid, so it's 1/3 times the area of the base times the height up the center. And if you multiply that, you get 175 over 3 inches cubed. For the surface area, it's the area of the base plus 1/2 times the perimeter of the base times the slant height. And if you calculate that, you get 115 inches squared. Let's see more examples with pyramids. In example 4, we're given this cone, which I consider a pyramid because it does come to a point. And again, they want surface area and volume. So we're going to start by finding the area of the base and the circumference of the base. But notice we also need to calculate the slant height. And notice what shape this makes. We have 15 inches here, 8 inches here. That looks just like a right triangle. So we're also going to use Pythagorean theorem. For the area of the base, I just did pi times the radius squared. The radius is 8, so you get 64 pi. For the circumference, it's 2 times the radius to get 16, and then times pi. For the slant height, like I said earlier, I used Pythagorean theorem. 15 squared plus 8 squared equals L squared. You find out that the slant height is 17. Now for the volume, it's 1/3 times the area of the base times the height, and you get 320 pi inches cubed. And for the surface area, it's the area of the base plus half the circumference times the slant height, and you get 200 pi inches squared there. Let's take a look at some examples with spheres now. In part A of this example, they've given us the sphere and they just want the volume and surface area. So we have the radius, so all we have to do is take the 9 and plug it into our formulas. The volume formula is 4/3 pi times the radius cubed, and if you calculate that, you get 972 pi centimeters cubed. The surface area formula is 4 times pi times the radius squared, and if you calculate it, you get 324 pi centimeters squared. For part B, notice they've given us half of a sphere, known as a hemisphere. So we need to divide our volume formula in half and our surface area formula in half to calculate this. So all I did was I put an extra 1/2 here in the formula. So volume is half of 4/3 times pi times the radius cubed, which gets you 128 pi over 3 meters cubed. The surface area, again, I added that 1/2 times 4 pi times the radius squared, and I got 32 pi meters squared. We have one last example about this. In example 6, we're asked to find the diameter of a sphere whose volume is 972 pi inches cubed. So what we're going to do is we're going to use the formula for volume of a sphere, plug in everything that we know, and then solve for the radius. So what I did is I took the volume that they gave and I put it into our formula. Now I have to get the r cubed alone. The first thing I'll do is divide by pi. Then I'll multiply by 3 to get rid of this 3 in the denominator here. Then I'll divide by 4 to get the r cubed alone. And finally, I'll do the cube root of 729. Most calculators are able to do that. On mine, I have a TI-84. If you hit the math button and it's number 4, we'll do a cube root. And then you type in your 729. So the radius turns out to be 9. So if the radius is 9, the diameter is going to be 18. So that's it for this video. I hope it was helpful. Let me know if you have any questions.